Are you still using lists for inserting and removing elements at the front? What if I told you there's a faster way? If we run this code, as you can see from the output, the deque finishes over 100 times faster than the list, but why? In this video, we'll compare a Python list with a double-ended queue, in other words, a deque. And you'll see why a deque can be 100 times faster in certain situations. We'll also cover useful deque operations that make a deque a popular choice for data structures and algorithms. Magandang araw, ako si Kuya Code. In this video, I plan to cover the basics and usefulness of a double-ended queue, especially when compared to a list. So let me go ahead and get rid of this from the previous section. So firstly, a Python list is implemented as a dynamic array, which means each element is stored in contiguous memory. When we append an item to a list, it simply adds it to the end, which is very fast. Likewise with pop, where it removes it from the end. The problem comes when you try to use insert or pop at index 0. Every other item must be shifted one position, making the operation very slow. So as this, we'll do a quick example here. So imagine we have a list here, and I'm going to make this a bit bigger actually as well. We have a list here, just simply 6 to 10. And then what we're going to do is just lst equal dot insert. Index 0, we're going to add a 0. And then lst dot pop 0, and then we can just print lst to see the results. So this is the original one, this is the insert, and this is the pop. We'll go ahead. So we have the original one from 6 to 10. We insert a 0 at the very beginning, which is right here. And then, of course, we pop 0, which removes the exact same one. So here's an example. So when we go ahead and insert 1, there's no space here. So we have to take this 10, move it over. Take the 9, move it over. Take the 8, move it over. Take the 7, move it over. Take the 6, move it over. And then we can finally add the 0. So that's basically what happens. And the same thing when you remove it, you simply delete this, but now there's an empty gap here. So this 6 needs to be moved over, the 7 needs to be moved over, the 8 moved over, the 9 moves over, and then the 10 moves over, and then this is just like chopped off. So that is the reason generally why it's very slow. But when it comes to a double-ended queue, it's implemented as a doubly linked list, so you don't need to shift anything. So for example, if we have a doubly linked list with more than, let's say, 8,000 items, if we have, let's say, item 7,000, it's linked to item 7001, that's linked to item 7002. If we were to go ahead and delete this, well, now item 7000 is no longer pointing to anything because we deleted it. So all we really do is it automatically takes item 7000 and points it to item 7002. So you don't need to shift anything because you're basically just changing a pointer from the old element that doesn't exist anymore to the new element. That's why when you remove something or add something to the very beginning, or you remove something, add something to the very end, it's just as fast either way. So there's a lot of algorithms that use doubly linked lists. An easy example is depth first search. So we'll just go into some basics for the double-ended queue here. So I'll just remove all of this. I'll keep this for now. So deque equals deque, and then we will just put in 2, 3, 4 for now, and then just some basic operations, which are very similar to how a list. Basically, they're the same as the list operations. It's just that they work a bit differently. So we can still append something. Appending it adds it to the back, so we'll just put a 5 there. We'll just print the deque here. As you can see, it prints it like normal. And then when we append 5, it just literally adds the 5 to the end, which is exactly what we expect. And then we could also deque dot append left. We'll just add a 1 to there. And then we will go ahead and print that. And now we have a 1 at the very beginning. So now we have 1, 2, 3, 4, 5. And then what we can also do, which is very interesting, is we can take deque and extend and then we could just type in more values to add to the end as an actual list. So we already have a list here, so let's go ahead and add the list to the end, and we'll go ahead and print it out. So now we have the 1, 2, 3, 4, 5 that was already there from our original double-ended queue, but now we also have 6, 7, 8, 9, 10, which was extended. And then likewise, we could also extend it on the left side. So we can just do deque dot extend, extend left, and I'll do it like this. We'll just do -3, -2, -1. We'll go ahead and print that. The one thing here about doing extend left, it actually adds it in the reverse order. Well, not really reverse order, but it'll add the 3, and then it'll add the 2, and then it'll add the 1. So we could actually just take that reversed and then do it like that. That way we have -3, -2, -1, 1, 2, 3, etc. I guess we're missing a 0 here, but that doesn't really matter. Okay, let's go into some more operations. So we can also rotate the entire thing, which is interesting. Because everything is just basically linked through a pointer, we could just basically take the pointers at the end and do some bit of changes to those ones in order to have them all, shifted by 1, and you don't really have to iterate through the whole thing because most of them are still going to be linked to the same one. So we take deque, rotate, we'll just rotate -2, and then we will just print deque again. Oops, print deque, and then we'll deque, rotate 2 just to go back like that. I'm going to turn these ones off. What happens if we go ahead and submit this or go ahead and print this? So we have it, the regular one we have, which goes from -3 all the way up to 10. But now in this case, all of the elements here were moved to the left. So now this is the first one. This -3 and the -2 just simply go to the other side. So it's rotated, and then you can do the same thing, which brings it back, which rotates it the other way, which is cool. There's also one, you can kind of reverse it as well, deque, which is pretty self-explanatory, deque dot reverse, and then print deque. Go ahead and print that. It's the same thing, but it's reversed. And let's see here. I think there is one more or a couple more that we can do. Obviously we can remove. So let's say deque dot remove. This removes the 3. So if we print this, 3 doesn't exist anymore. It skips over it, and then we can just add, or we can insert 1 at a very specific index. Or actually, we'll just add it onto the back for now. So deque dot append 2. So you can see that there's 2 of them. I'm going to do this. And then now that we actually have 2 of them, we can just simply call deque.count. And you're going to count how many 2s there are. So as you can see, there's a 2 there, and there's also another 2 here, and we can count them. There's 2 2s, which is pretty good. There is also something that you can do, which is max length when you make a new double-ended queue. So we'll just call this limited deque, which the maximum length is 5. So if we were to go ahead and make a new one with 1, 2, 3, 4, 5, and then we have a fixed size like this, I will just delete that. We'll have 1, 2, 3, 4, 5, it's max length. And what that does is that when you go ahead and append 1 to the end, if it's more than the max length, it'll automatically remove 1 from the opposite side. So that means if we add a 6 to the end, and then we print it out, we should expect it to automatically remove this 1 from the other side. And that's exactly what we have. We have 1, 2, 3, 4, 5. It automatically deleted the 1, added the 6, and now we have 2, 3, 4, 5, 6. So now what we'll do actually is we'll just add an extra one because currently our limit is 5. So what happens if we try to insert one in? Well, it's insert 3, 25, and we'll go ahead and run that. And this gives us an error, and what does the error say? The deck is already at maximum size. So when you would normally append, it seems it would work because it would just remove the one on the front or whatever. But when you go to insert, it'll just cause the error. So that is something to keep note of as well. So now we'll just go ahead and do the coding challenge on the site. So I'll go ahead, go to Python. We'll go to easy. We'll go to collections. I think we only have one more in the double-ended queue left anyways, which is good. And these challenges are pretty similar to ones we've done before, where if you look at the sample input, we have 6 inputs here, which is these are the 6, and then we have to do an operation for each one of them. So like I said, this is very similar to like a dictionary or like a list one. So it's pretty straightforward. The only addition is that we're going to be appending left because this one obviously doesn't really exist in a list. You would just use insert in that case, but like I said, insert is slow. So we'll just start from collections, import double-ended queue. We'll take our n int input, and then we need to make a deque. So there's our deque there, and then for underscore in range n, and then we will go ahead and get our line. We'll go ahead and split that, which is, of course, is going to split up the command from the actual number itself. And one other thing to consider, though, is that when you use pop, it doesn't actually have a second one. There's only a single one for pop and pop left, where these ones actually have numbers. So in some cases, line is only going to have a length of 1. In other cases, it's going to have a length of 2. So that's something we also have to consider. So if line at 0 equals append, then we can just simply d.append, and then int to convert the twin of line at 1. So in this case, this is your line. Line 0 is append, which means line at index 1, which is right here, gets converted to an int, and it just adds it to the deque. And then that'll do these 3, and the next one is append left. So we can just kind of copy this, move it down. This one, if it is append left, then we will just append left. elif line, not loop, line 0 equals pop. Obviously, we don't have another number, so we can just do d.pop. And then the last one, line at 0 equals pop left. Then we can do d.pop left. And then what we can do, of course, is for I in d print. Actually, let's see if we can do it like, we're expecting that to be a space, which means we can probably just print. Let's try the unpack operator, see what that does. Did I from collections? There's a typo. All right, that was successful. Go ahead and submit it. It looks like we are good to go. So if you found this video helpful, please like and subscribe for more coding challenges. Let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuyuko. Paalam.